Hi, my name is Florian from Quality Guru. I answer your questions and share knowledge about quality management. And today I want to talk about significant versus critical characteristics. Significant and critical characteristics. This is a concept coming out of the automotive industry. Here it is particularly known because there are so many requirements regarding the products, and there's a lot of strong quality management systems in place that standardize each and every activity. So sometimes it's difficult to see the wood for all the trees. That means there are so many requirements, and which are the ones that are most important, that we should focus most on. And here the concept was invented of significant characteristic and critical characteristic, that we can apply the SC and the CC label on the processes, on the aspects of the product that are most relevant, and by this communicate the importance of this to the organization, that everybody can see, oh, this is an SC, this is a CC characteristic. That means I need to pay special attention here. So let me give you an example based on a product, like, for example, a headlamp in a car. That means the headlamp is the product that shines light on the road and helps you to see the road even in the middle of the night. And here it could be that we have different characteristics, like, for example, safety, legal, or functional characteristics regarding to the product. And by definition, the safety and the legal, they are called critical characteristics, so we short CC. And on the functional side, we have the SC, the significant characteristics. This is because it's significant. What goes wrong here, a failure mode in this area, is significant because a customer will be affected by a loss of function of the product. But maybe it's not so critical like a safety or a legal issue, because, of course, if my radio doesn't turn on, it's not so critical like when my lights are not turning on, because if my lights are turning on, I could have a safety issue because I could crash into an object and die or kill others, harm others. And on the other side, if a functional issue happens, this is something that is inconvenient. The customer, of course, will be not happy, but it is not putting at risk life of others, and also there is no legal consequences in terms of that the product is now an illegal product and needs to be taken out of the market. So there's a certain quality that makes the CC a little bit more severe. That's why also in an FMEA, when we talk about them, we would normally give a 10 or a 9 for the CC and maybe an 8 for the SC criteria. Okay, let's look at an example for the headlamp. When we say, for example, safety, what could go wrong with this headlamp that makes it a safety issue? And the most obvious thing is that the light is not working. So for example, you're driving in the night, the light is there, but suddenly the light is turned off. What a safety risk. Okay, when we now look at our quality management system, we could say, okay, what would be a possible root cause of this, that the light goes on? And this root cause is then the critical characteristic. It's the characteristic I have to take care of and ensure that it's working 100% in order to ensure the function and avoid the safety risk what we just have identified. So it could be that there's a risk with the safety or with the light on. Okay, let's go on to a legal issue. The lawmakers, in order to protect the consumers and everybody in traffic, put certain regulation on the vehicle makers like BMW, GM, Nissan, Toyota, and whatnot. And they have to fulfill certain requirements. So for example, for a lamp, they have to fulfill the requirement that the light is distributed in a certain way and that the aiming is in a certain way. Because if the aiming is not in a certain way and the distribution is not in a certain way, it could be that, first of all, the driver is not seeing enough. Maybe if the aiming is very low, it only sees a very short area in front of the car. But also in the other way, if the aiming is very high and the light distribution is very bright, too bright, it could be also glaring the other participants in traffic and then put at risk other people. So there are also legal requirements, and you can already see that legal and safety goes together often because the lawmaker is making requirements because of safety risks to protect the people in the country, to protect the participants in traffic. So legal requirements often goes hand in hand with safety. That's why CC characteristics are safety and legal at both times. Good. And then last but not least, what could be a functional issue? A functional issue could be that a certain animation in the lamp is not working nowadays. You can go with your remote control to your car and the car will do something, will do a greeting function, go up and down, left and right, blink maybe several times, make an animation, all these kind of things. You paid for it if you are the owner of the car. If it's not working, of course, the owner is not happy, but it is not as severe as a legal or a safety issue because no person will get harmed if it's not working and no legal consequences in terms of car homologation. That means that the car has to be, that there will be no recall for a car based on legal requirements. Maybe to make the customer happy and to fix this kind of function if it's necessary, yes, but there's a different quality to it because one is just the function and one is a higher risk like legal or safety. So now let's go, last but not least, and see an example of how this applies, how to control now these SC and CC characteristics in our company and why is it helpful to apply it. And here we can say, for example, let's take the example of the headlamp and say the headlamp is not turning on or suddenly in traffic is suddenly turning off. And then you have the safety issue because the car is driving without light and that is a risk for everybody. What could be a possible root cause for this that we need to control? And a possible root cause for this could be that the electricity, the power connector is not sitting very well in the socket and that it has fallen off. It has fallen off and now there's no power anymore. The car was driving, it was moving and then it was not properly connected and then it fell off and then there was no light anymore. So it could be that this connection of the connector into the power socket is a critical characteristic. And let's go now through the whole design process to see how this can be avoided or how can we use the critical characteristics logo to signal to the organization and show everybody, hey, here you have to pay attention. The connector needs to be always connected in a certain way. First of all, normally when we design a part, we look at we create a drawing, we create an image and say, okay, here, this is what we want to build. This is what we want to create. And in this drawing, we can say, okay, this should be this diameter and this should be this size and should be this color and should be made out of this material. We can specify everything to show what we want to build. And once we have an image of what we want to build, we can also discuss this in a design FMEA, that we say, okay, it needs to be built in a certain way so that everything fits together in a certain way. And if it doesn't fit together, maybe there will be problems. We can work them out in the design FMEA. And specifically to the connector issue, if we say, okay, a connector needs to fit in a certain socket, maybe it's important that the socket is defined in a certain way. So we can say it must have a certain dimension, a certain width, a certain height. The tolerances needs to be in a certain way, not too big, not too small, so that the connector can fit perfectly inside. Because if it's too small, the connector will not fit in, but if it's too big, maybe it will be loose and then fall off later, leading to the problem that we have identified. So we could define in our production process, in our design process, that here this dimension needs to be controlled, and then the quality guys put it in the control plan and monitor always this dimension. Maybe 1 in 100 pieces, they measure the dimension to make sure that it is controlled and that we avoid this safety issue. We can then also look into the PFMEA, into the process FMEA, and see how do we control it in the process. So now in the design, okay, we control the dimension, okay, but maybe also in the assembly process of plugging the connector, we also need to ensure that it's plugged in a certain way, maybe in a certain depth, with a certain force, with a certain positioning. Maybe there is a lock that we have to click in to make sure that this connector never, ever falls out of position. So this one we can define in the process FMEA. We can also put it into the control plan that we supervise or measure in a certain frequency how deep the connector is plugged in, or certain things similar to that. And then last but not least, we can also put it into the work instruction. so that the operator who gets trained in this kind of process, how to plug in the connector, also knows, aha, this is a CC characteristic. I need to plug it in a certain way. Otherwise, it can lead to severe consequences, safety issue, people having no light in the car, and then running the risk for life and health. And we also want to show it then in the workstation, that we label on the workstation where the people are working the label of CC on a certain workstation, so that when you go into the production line in the factory and you see, okay, here are many stations, but what are the most relevant for our quality? Then you say, here, SC, here, CC. So explain to me what is going on here. Why is it relevant to the quality of the part? What do we have to pay attention to? And this is the magic, that we can go up and down in this chain. If you find out, okay, you have a significant characteristic or critical characteristic that affects severe failure modes in the market, then you can also go back to the design and say, okay, do something in the design to take this risk already out. Do some poka-yoke design to avoid that I carry over this risk into my production process, because there maybe things can get out of control, and it's better to avoid it from the beginning in the design. So all in all, this is the idea of significant versus critical characteristics. Please leave a comment if you are also working in automotive industry, if you are familiar with this concept, and leave a like and subscribe if you get value out of this. See you in the next video.